So part 2 of the video, we're going to do solving simple trig equations. And at the end of the video, I included the graphs of all the trig functions and some of the inverse trig functions just for your notes or to help you review some pre-cal concepts. So starting out with a simple trig equation. Let me put up something as simple as the cosine of theta minus root 3 over 2 is equal to 0. So this is what we consider a simple trig equation. Simple because you won't be using too many of those identities to go through and solve the trig equation. When you're looking at cosine of theta minus root 3 over 2 equals 0, we are using the same rules that you know for solving for x. You want to get the variable on one side by itself, so we're going to add root 3 over 2 to both sides. And we get root 3 over 2 here. So solving is interesting because sine and cosine, all of our trig functions are periodic. So there's actually an infinite amount of answers to this question. We're going to solve our trig functions to go from 0 to 2 pi just to make it a little bit easier for us. So for this problem here, I am going to start off with step 1, which is figuring out where cosine of theta would be positive. Since we added root 3 over 2 to both sides, your result is positive. So I'm really going to be looking for an angle whose cosine value is positive root 3 over 2. Cosine is positive in first and in fourth. So there's 2 answers. The next thing we have to look at is which point gives us root 3 over 2 as the x value. Well, the y value would be 1/2. This happens at pi over 6. So in case you're having trouble, I'm going to paste for you that little unit circle off to the side one more time so you can use it for reference. So it is definitely pi over 6. So to complete this problem, you would need to figure out which pi over 6 is in the first quadrant, and that's easy. That's the regular 1 pi over 6. You'd have to figure out which one is in the fourth quadrant. Now the fourth quadrant's a little bit harder. This is 6 pi over 6. This is 12 pi over 6. Go back 1. That means it's 11 pi over 6. So our other answer is 11 pi over 6. The answer to our question up there is pi over 6 and 11 pi over 6. So the second problem I want to try out is going to be, so I'm going to move this over a little bit. I want to solve the equation of cosine of theta minus, or equals, sine of theta, cosine of theta. And most of you would probably say the first step you want to do is divide by cosine. That is not what we want to do. We actually don't want to divide out a trig function. If you're going to physically lose your trig function, you don't want to do it. So instead, what you're going to do is subtract the term to the other side. When you do that, you can actually factor out the common term. When you factor out a cosine of theta in front, you're left with 1. In the back term, you're left with negative sine of theta. So we get 2 factors. One factor, we have cosine of theta equal to 0. The other factor, you have 1 minus sine of theta equals 0. We get that theta, when is our theta going to be 0 on the unit circle? That's whenever our x value is 0. So that's up top and down bottom. So that's pi over 2 and 3 pi over 2. For the problem to the right, a little bit different. Negative sine of theta is equal to negative 1. Therefore, sine of theta equals positive 1. When is your y value positive 1? It's at pi over 2. So your 2 answers, there aren't 3, there's only 2, are pi over 2 and 3 pi over 2. So this is some simple trig equations that we're looking at. I want to go through one that's going to be a little bit harder. And let me insert a page here. So I just realized that I think I want to do that in a later lesson because we don't really need it just yet. What I will do is go through a problem that applies to what we're doing now. So a problem that would be helpful would be find the equation of the tangent line at x equals 2 pi over 3, where f of x is equal to the sine of x minus minus x equals, oh, no equals in the back. So there's our function. F of x is equal to the sine of x minus x. So let's review one thing to start, which is we need a tangent line. Tangent line, you need a point, and we need a slope. How do we get the point? Well, we actually have half of the point. Therefore, we need the y value. The slope we get from f primed of x. And we're going to be finding this at 2 pi over 3. So these are all the pieces that I need to this puzzle. Let's start off with finding the y value at 2 pi over 3. So we'll do the sine of 2 pi over 3 and minus 2 pi over 3. This isn't a very nice problem, but so let's review. Sine of 2 pi over 3. Do this in black off to the side. 2 pi over 3, so this is 0, this is 3 pi over 3. I would be in this quadrant. Sine there is positive, so I know my answer is positive. And 2 pi over 3, the point would be 1/2 comma root 3 over 2 for anything that is a pi over 3. Sine is root 3 over 2. So positive root 3 over 2 minus 2 pi over 3. That is our horrendously ugly y value. Now, what you can do to it is get a common denominator, which would mean multiply this one by 3 over 3, multiply this one by 2 over 2. And we get left with 3 root 3 minus 4 pi over 6. To me, having one fraction is always much easier to work with, so I am going to use that. Now, next thing, we've gotten our point. We just found that. Now we need our slope. We find our slope by taking the derivative of our function. The derivative of sine is positive cosine. The derivative of x is 1. We need to find this at the point x equal to 2 pi over 3. So I'm evaluating the derivative at 2 pi over 3, which we just evaluated the function at 2 pi over 3. Okay? Just making sure you notice we did it for the function and for the derivative. So the cosine of 2 pi over 3 minus 1. We're going to do cosine off to the left in red. 2 pi over 3. So you'll notice you're using the exact same point again. And so the point there, the only difference is we're in the second quadrant, so cosine's actually negative there, and cosine will be using our x value. So we know that the cosine of 2 pi over 3 is actually negative 1/2. So we get negative 1/2 minus 1. Therefore, we have negative 3 over 2. Give it a second. What did we just find? This is the slope of f of x at x equal to 2 pi over 3. Now we have the slope. We are good on this point. We're good on the slope. That means I should be able to write the actual equation. Move this out of the way. I'm going to put that in this box right here. Y minus y1 is equal to m times x minus x1. So, in blue, y minus the y of the point, which is 3 root 3 minus 4 pi over 6, is equal to the slope, negative 3 over 2, times x minus And just because I'm running out of space here, x minus 2 pi over 3. There is the equation of the tangent line. So you can kind of see that in learning the derivatives of trig functions, you end up using a lot of what we just went over in terms of review from pre-cal to help you evaluate derivatives, make the equations of tangent lines, find the point at a certain x value. The last part of this flip chart just has some graphs for you. It goes through the domains and the range of each function. What I want to highlight for each of these is the fact that the domain for sine and cosine are all real numbers, but you'll notice that tangent has asymptotes. You'll notice that cosecant has asymptotes, secant, and cotangent. After that, I gave you the inverse function graphs. Okay, these do not go on forever. These have points here and here that stop, here and here that stop. And the last one is tangent. And the thing about tangent is that at pi over 2, which is about 1.57, you actually have an asymptote. And at negative pi over 2, you have an asymptote. So that is my extremely fast review for our pre-cal concepts.